Now, Hawks will let you leave your equation in this form, but I prefer it to be back into the slope-intercept form, and I really want it that way so that I can graph it here on this graph. So I need to distribute this 3/2, so I'll put that right up here. Y plus 1 equals 3/2 x plus, and if I take 3/1 times 3/2, I get 9/2. So I'll put that in, 9/2. That's for multiplying right here. And then I want to subtract 1 from both sides. And I have y equals 3/2 x. And then I have 9/2 now minus 1/1. And I want to build it up so they have the same denominator. So I'll multiply this by 2/2, a form of 1 here. And I have 2/2 now. So 9 minus 2 is 7/2. So I have plus 7/2. Now I know that my slope is 3/2 and my y-intercept is 0, 7/2. So I can go 0 in the x direction, 2/2, 4/2, 6/2, 7/2 right there in between. And I already have this other point on my line, and you can see, if you can see my traced line there, it's very close. I can also go from this known point that was a nice through -3, -1, and go rise of 1, 2, 3, run of 2, and find yet another point on my line that's an actual cross of the grid marks. So now I've got 3 points, so I can go ahead and graph this one. And you can see that this is perpendicular, and it goes right through this -3, -1. Right, let's look at another one. Find the equation for the line through this point that's parallel to x equals 6. Well, I better take a look at x equals 6, and I see that I only have one variable, so I know it's going to be a special case, one of either a horizontal or a vertical line, and I'm not quite sure, so I'll make an xy table, and I see that no matter what, x has to be 6, so I can plug in 6 for every point for the x part of the coordinate, and then the y part I can put 0, 2, and 4. It doesn't matter as long as my x part is 6. So then I can graph it, 6, 0, right there, and then 6, 2, and 6, 4. So I have a vertical line, and if I'm looking for a line through here parallel to the x equals 6, it's also going to be vertical. So I can go -1, -2, -3, and go -3/3, 4/3, almost to a -2. And I know that has to be vertical because it has to be parallel to the one I've already drawn. So I'm pretty sure that this is my line. And then when I try to figure out what its equation is, I know I can go, I have one of my points already, a -3, -5/3. But I can see also that -1, -2, -3, 0 is a point, -3, 2. And so if I look at my xy table, I can see a pattern that my x is always a -3. So that's the equation of my line that's parallel to x equals 6. Now if I wanted to do a little bit quicker, I could think about my xy table for x equals 6, and my x part is always the 6. So I could think, well, this x part has to stay the same all the time for it to be vertical, so I must need x equals -3. Now if I wanted it perpendicular to x equals 6, then it would have to be a y equals, and I would use that y part there. Alright, here's one for you to try. Find the equation for the line through -3, 0 perpendicular to this equation. when I look at this equation, I want to know what's the slope. And so I will put it into mx plus b form. Negative 3y equals negative 6x plus 5. Divide by negative 3. And I end up with y equals 2x minus 5/3. So my slope here is a 2, or a 2 over 1 if I want to use it that way. And I need a perpendicular slope. So my perpendicular slope is going to be negative 1/2, because I have to flip this over and flip the sign. So now I want the equation of the line with a slope of negative 1/2 and a point of negative 3, 0. So I need to use my y minus y1, my point slope formula, m times the quantity x minus x sub 1. This is my x sub 1, my y sub 1, and there's my m. So y minus 0 and negative 1/2 for my m, x minus my x sub 1 is negative 3. So I have to put minus a negative here. Y minus 0 is just y, negative 1/2 times the quantity x plus 3 now, and then distribute that one negative 1/2, so I have y equals negative 1/2 x, and then negative 1/2, I'll write that over here, times 3 over 1 will be negative 3/2. And there's my equation. Let's see what all this means and how we can use it to help us graph things. Jackie bought his car in 2004 for $41,000. His car was worth $24,000 in 2009. So we want to know what's the depreciation, and the annual rate of depreciation we can think of as dollars per year, and we want to reduce it so that it's dollars per 1 year, and that'll give us $4,000 a year or something like that, what the depreciation is. So we want to look at this information in our original problem and see, do we have information like that? Remember, if we're looking at slope, this is the change in the y's over the change in the x's. So we would want to think the years are the x's, so year, and the money, dollars, are the y's. So if we're writing ordered pairs, we'd like to put them in the order year for the x part and dollars for the y part, because then what we'll come up with for the slope really makes sense. So year for his first, when he bought the car, it would be 2004, and it was $41,000. And then we have another data point now, or in 2009, so we can put 2009 for the year and 24,000 for the value. So now we have two ordered pairs, and we would like to see what is the depreciation, and it's really the slope. So we can look at the change in the y's over the change in the x's. So we would do 41,000 minus 24,000, and then 2004 minus 2009. So if we do 41,000 minus 24,000, we get 17,000 over 2004 minus 2009 is negative 5. So we have a negative slope, which means our line is going down, which is appropriate because the value is going down. But we want it to be over 1 because it makes a lot more sense to have it in that fashion. So we take 17,000 divided by 5, and we get 3,400 over 1, and we have to have a negative somewhere. So negative 3,400. So what's the annual rate of depreciation of his car? The depreciation is the same thing as this negative, so we don't need to report it. We can just say loses